The Chinese J-10 fourth-generation fighter aircraft flies with a massive arsenal hanging from more than 11 hardpoints or pylons under the fuselage and wings, drops laser, satellite-guided and glide bombs, and fires a wide range of air-to-air and air-to-ground weapons. U.S. Air Force F-15 versus Chinese J-10 fighter. The aircraft, in existence since 2005, forms a key foundation for the People's Liberation Army Air Force, can also hit extensive ranges of 1,400 miles and take off with a full load of extra fuel tanks and 42,000 pounds or ordnance. The PLA Air Force operates more than 540 J-10s, according to a citation from the International Institute for Strategic Studies, a number which presents a clear ability to mass in air formations against an adversary. While a fourth-generation aircraft, the J-10 Chengdu was engineered with a series of modern technologies, perhaps with a mind to overmatch 1980s-era U.S. Air Force F-15s and F-16s. Some of the systems built into the J-10 are listed in an interesting write-up from Cyto Defense in 2010. The essay describes the J-10 as operating a multi-mode fire control radar and a mechanically scanned planar array antenna capable of tracking up to 10 targets. The essay says up to 2 targets can be engaged simultaneously with semi-active radar homing missiles, or 4 can be engaged with active radar homing missiles. While the ability to track multiple targets is indeed quite significant, as it is likely intended to match the N/APG-63V1 radar upgrade on U.S. Air Force F-15s. As an upgrade to the APG-63, the V1 version allows the radar to simultaneously engage 6 targets and track as many as 14. The APG-63 V1 radar armed many F-15s in the early 2000s, but in 2000 Boeing and the U.S. Air Force took a major step in adding an AESA radar to the F-15 with the APG-62 V2, perhaps in an attempt to surpass the then-emerging J-10. The AESA radar, a variant of which does not arm the F-15EX and even the F-35, massively increases precision to detect trajectories and destroy multiple targets at once, with far greater effectiveness than traditional radars. In an AESA system, the traditional mechanically scanning radar dish is replaced by a stationary panel covered with an array of hundreds of small transmitter-receiver modules. Unlike a radar dish, these modules have more combined power and can perform different detection, tracking, communication, and jamming functions in multiple directions simultaneously. China's early applications of radar, fire control, and targeting on the J-10 have doubtless been upgraded as well. One reason the U.S. Air Force has continued rapid computing and radar upgrades for its F-15s and planned to fly the jet well into the 2040s. It would indeed be interesting and significant to determine the extent of PLA Air Force upgrades to the J-10 in terms of what technologies they may consist of for purposes of comparing it to today's F-15. Some of the enhancements to the J-10 include the incorporation of the WS-10B domestically produced engine. Like a U.S. Air Force F-16, the J-10 is built with a bubble canopy to ensure a 360-degree surrounding viewing angle for the crew. The pressing question with the J-10, it seems, is the question about the extent of the upgrades. For instance, should the aircraft have received high-speed computing, high-fidelity, longer-range sensors, and targeting in new generations of weapons, then perhaps it too could fly into the 2040s as a credible rival to the U.S. F-15. Also, the extent of weapons upgrades would be critical, as the J-10 can carry a large payload of weaponry as if it were a bomb truck to a degree. Given that aircraft is large and not as fast as other fighters, it's unlikely the J-10 would present a huge dogfighting threat. The potential extent and effectiveness of its upgrades would likely determine the extent of the threat it presents to the West. F-15 upgrades. For the last several years, the service has been in the process of testing, engineering, and integrating a new Eagle passive or active warning and survivability system, EPAWS, into its fleet of F-15s to, quite simply, keep pace with fast-changing threats. By operating in passive or active mode, the EPAWS can perform both offensive and defensive missions, such as finding and jamming enemy radio communications, detecting the electronic signature of incoming weapons, or simply sustaining an EW-enabled operational presence. Passive mode allows the EW system to in effect listen for enemy signatures while not giving off a signal itself. This can be of great significance given that once any kind of electromagnetic signal is emitted, there is naturally a risk that it could be found or detected by an enemy. At the same time, having an ability to operate in active mode is also critical as it can enable the aircraft to disable ground firing systems, air attacks, or even enemy drones. The EW warfooting draws upon various key techniques, such as finding what's called a line of bearing or signal origin toward which to intercept or direct an attack. These updated EW capabilities replace the Tactical Electronic Warfare Suite, which has been used since the 1980s, not long after the F-15 first deployed. The service plans to operate its F-15 fleet until the mid-2040s, so an overhaul of the Eagle's electronic systems helps maintain U.S. air supremacy. Boeing won the initial contract for the EPAWS project several years ago and has since hired BAE Systems as the primary subcontractor. As a fourth-generation fighter, an F-15 might run the risk of being more detectable to certain kinds of advanced modern enemy air defenses. However, if it is upgraded with advanced sensors, weapons, and EW, it would certainly be much better able to operate combat missions in extremely high-threat scenarios. An interesting report from the Air Force Test Center describes the current system as one using outdated analog technology suited for threats expected years ago. EPAWS takes advantage of today's computing, receiver, and transmitter technologies to provide quicker, smarter response to threats, getting better actionable information to the pilot. The service report further specifies that EPAWS can succeed in detecting RF and IR, infrared, threats by acquiring accurate targeting information prior to threat engagement. Overall, the U.S. Air Force is vigorously upgrading the 1980s-era F-15 fighter by giving it new weapons and sensors in the hope of maintaining air-to-air superiority over its Chinese J-10 equivalent. The multi-pronged effort not only includes the addition of electronic warfare technology but also extends to superfast high-speed computers, infrared search and track enemy targeting systems, the addition of active electronically scanned array radars, increased networking capabilities, and enhanced weapons firing capabilities.